Hello. So in this particular session, we'll be talking mainly about how exactly one can design the object code format. Now, there are multiple steps involved. Like as in a translation perspective, we do give switches to the command for translation purpose. Say, for example, when you write gcc-c program name.c, so it gives you an object code generated in ELF form on Linux, uh, basically. So similarly, if we are trying to create our own object code format, we'll be following the steps that we'll be discussing in this session. So important step one here is we have to define the purpose and requirement of that object code format. So initially we would be talking about targeting the considering the target architecture. Now here, our basic aim would be to find out what kind of object file target that we want, whether it would be meant for x86, ARM, or RISC-V. Nextly, we have to find out whatever the object file that would be creating. Will that file be linked into an executable, or it would be part of some dynamic or shared library? Further, we have to find out, or we have to decide whether we will need support for separate compilation, because we may require that object file for file generated for linking multiple object files together at the later stage. Further, we have to even discuss or maybe think about whether the object file would be including debugging information. Another important aspect is, do we want that format to be platform independent, or we want it specifically for a particular operating system? And while talking about this purpose and requirement, we have to also see whether the object file would be statically linked, dynamically linked, or it would be linked in both parameters or both ways. So secondly, we have to find out components of object code form. So right now, what we'll doing is we will try, like if at all we have to find out or we have to come up with an object code form. So what should it contain? So first thing, like every file generally has, is a file header. Now earlier object code formats may not have that, but right now while we are talking about the current era of 32 or 64-bit world of processing, we will require an file header. Now this file header would be important part of your object file, and it contains essential metadata of that file. So magic number is one of the important part. This would be an identifier uniquely defined, which will let us know that the file is an object file. Correct. So like we can definitely get information about magic numbers from various sources on internet. Nextly, we have to come up with some version as well. Like if we want to provide backward compatibility, then we will require this. So like if you don't require that thing, you can definitely skip it. But version of the object file format would be important. Even we have to specifically add target architecture into the file header. Nextly, whether our object file format would be following Indianness or not. So Indianness would be either a big Indian form or little Indian form. We have to also define in file header what would be the entry point if the object file is executable. Okay. So we have to specifically add that entry point. This would be an address where your execution will start. Even we have to add size of sections. Now this is optional most of the times, but it would be good if we have sections with varying sizes. Now, if we are having sections with varying sizes, then this header would give us information about the offsets used inside. Next, we need to add a section table. Now, this section table would be used to map the sections that are available within your object file. Now, here, like each section will have its own data type and size. Say, for example, like text section or code section contains machine code, definitely an executable a set of executable instructions. Data section containing initialized global and static variable. BSS, block starting with symbol section, contains uninitialized data, generally initialized to 0. We will require read-only data section as well, so which stores information about constants and literals. If we are going to provide a relocation, then we will require a relocation section, which would be storing these entries related to relocation. We have to add symbol table. Like this symbol table would be added through a section, so which will be mapping the variables that you used in the program as well as the functions with their respective addresses. Now, if you want to add debugging information, then ultimately this would be important to add the metadata for debugging. So which will contain basically the function name, source file name, even line numbers are added and so on. Now, if at all we have to adopt this section table rather, then we have to implement as an array or a list, depending upon whatever your choice is, where each entry would be specifying name, type, size, and offset of the section. Nextly, when we talk about symbols, so we will require information about the relocation too. Now, symbol table is a table, as we know, which would be mapping each symbol to a specific address or location in the memory. Now, what the symbol table generally contains? Symbol table will contain name of the symbol, type of the symbol, so whether it is a function or a variable. Also, it will contain address where the symbol is located in memory. Section, the symbol the symbol belongs to. Say, for example, one variable that you declare in data section, one variable that you declare in BSS, one variable that you declare in RO data. Each one of them are defined in different sections. Correct. So that information also needs to be stored. Further, we'll require relocation information. Now, this would be useful when we want to link that object file to create an executable. So it will communicate linker that if at all an object file is to be modified during the linking process, what entries are to be done. So this relocation entries would be used every time whenever address of symbol is not known to us. So it may be a function call defined in other object file. Okay. Even it will be required when there are some references used in the program to the symbols that needs to be adjusted when the object file is linked or when the object code is linked. Now, generally, these relocation entries consist location, address, or offset. Okay, within the section, definitely. The type of relocation, whether you want that relocation to be absolute or whether it would be a relative one, and information about the symbol to which the relocation would be applied. Nextly, we will require information about code and data, like machine code, like which is text section. This would be a raw machine code generated by your assembler. Okay, which is actual executable code. Now, when this code is generated, we know that this code would be completely organized into specific sections. For example, like with IA32, we have seen that it is in .text. Similarly, the data section contains all global static variables which are initialized in the source code. Now, like if we see implementation of data section ultimately in internal perspective, so it could also have information about constants or lookup tables which are added internally. Okay. Further, like if you at all you are providing debug information, so that as I mentioned here, that can be optional. So that would be your choice specifically whether to add it or not. But if at all you would like to include that, then you will require following things to be added so as to add the debug symbols. Now, if this would be important only when you want to support debugging for your code. So debug symbols would be like function names. Okay. Source file names, line numbers would be added, information about the variables with their types and locations. And this debug information may be stored in a dedicated section. Like for example, in the ELF32 file format or object code format, we do see that there is a .debug added, or like you may have it as a part of your symbol table outside, like which is not the symbol table related to your function or a program. Now, this can be thought of as a layout rather for an object code. So in general, like it would be seen like this: magic number, version architecture, section table, offset, section count, and then rest of the things would be added. So this particular picture is created with by referencing the ELF32 architecture, ELF32 file format. Now we will require something with respect to parsing that object code. So for that purpose, we will require parsing and writing logic. So here, writer, a program which would be taking intermediate representations like information about machine code, symbol tables, and outputs the file in your custom format. Like in your custom format means the object format that you want. So you will require to write these codes rather whenever we want our own object format to be created. Further, we will require a reader, or sometimes also called as a parser. Now this would be a program which would be reading your object file format. It will parse all the different sections included into that, and then appropriately it will create necessary information which can be useful further for linking or execution. Now another important program that you may have to implement for these object formats that you created would be a linker. Now this linker is supposed to take multiple object files. Now we know that those files may contain symbols, so we have to provide symbol resolution mechanism. We have to handle relocations too, and like either a single executable or a library, we have to create it as an output perspective for a linker. Further, like when we think of implementing linker and loader support, we need to have a mechanism where it would a linker program is needed for our object files, which will combine all object files together. And we also will require a loader or environment where your program can be loaded in memory by appropriately making adjustments into memory addresses when it is executed further. Then nextly, we will require the format to be tested. Now, if at all it is to be done, then ultimately what we'll require in that case is to see like whether whatever the format that is designed by us and we implemented it for say for reading, writing, linking, loading. So on Linux, you must have seen that whenever an object file format is taken, say for example ELF, you can make use of file command to see what is the file format for that object code. Further, like if you want to link, you use LD to link together. And when you execute through /a.out ultimately, which is the default file name on Linux platform, so it executes. So you will require some tools which would be dedicated for your object file format. So you can do thing like whatever the assembler that you implemented, you create small programs, assemble or compile them into your custom object file format and link them together. You can provide debugging features. Okay, like if at all you think you can implement. Further, you can perform performance testing, which would be required to ensure that the format is efficient enough for practical usage. Now, like you can think of working with kind of a toy object format, but further, like if you want, if you see that there is good opportunity to include that in some file format, you definitely can come up with by applying performance testing. Even you should think about this adding facility of backward compatibility and what are the extensions that you may wish to add at the later stage so that your format can be evolved without breaking existing functionalities. And lastly, you will require documentation for your object file format. Now, this would be important for the implementation of versions, different versions, as and when you add a few things into support to your object file format, everything needs to be documented. So what you should do rather while preparing a documentation, you can come up with a file layout, add information about relocation and symbol resolution, add tools, add a debugging information, and so on. And this is how you can design your own object file format for the assembler or maybe a translator that you are implementing for a specific language. Thank you.